So let's go ahead and perform these row operations on my original tableau, really to make the artificial variable non-basic. Okay, that's the first step. So notice that I've written the empty tableau here, and also row 3, because of course row 3 is my pivot row, so that won't change. So let's go ahead and perform all these operations on every one of these entries to get my corresponding equivalent tableau. Okay? So of course the first column is easy because on purpose we've performed these operations to make every other element 0 except for, of course, the pivot position there. So we should get a 0 here, a 0 here, and a 0 here. And then I'll go ahead and perform each one, and you should verify that these actually work. Okay? So if I perform all these operations, I get a 1, a 0, and a minus 3 when I perform that operation on that one. On this second one, we've got R1 minus R3, so 3 minus 1 is a 2. 3 minus 3 times this is 0, right? 3 minus 3 is 0. And 18 minus 15 is going to be a positive 3. Okay? Here I've got zeros, so it's just the same thing, right? Because it's 0 for R3, so it's all the same. It should be a 1, a 0, and a 0, a 0, negative 1, and a 0. Here it's just going to be exactly what A1 is, right? Well, I should say what the 1 is there because I've just got a 1 for all these R3s. So I should get a negative 1, a negative 3, and finally a negative 15, right? Okay? And because, of course, it's 0 minus the 1, 0 minus the 3, 0 minus the 15. And finally, this one should be the same as well because I have a 0 here. So 0, 0, and a 1. Okay, so let's look finally at the last column here. So if I take R1 minus R3, so 12 minus 10 is going to be 2. I've got R2, 18 minus 3 times R3, so 18 minus 30. Right? So 18 minus 30 is going to be negative. It's going to be a negative 12. And similarly here, I've got R4, which is 0. 0 minus 15 times R3, so it's going to be a minus 150. Okay? It's a 150 over here, minus 150. And it's okay that there's a negative sign here, because remember that really originally we were after the minimizing problem, okay? But we want to maximize the negative W. Okay, so in the end, we're going to have to change some signs around, but ultimately that's okay. Again, we're at a maximum problem. So that means that we have to keep going until all of our indicators are positive. Okay? So now the next step would be to look at our indicators and make sure that they're all positive. Well, clearly, we're not at a maximum because here's an indicator and it's negative. So that means that I have to use this column as a pivot column somehow. And I'm going to determine which one of the elements here is a pivot position by the usual test, right, the quotient test. So let's go ahead and do that. So I'm going to pivot one more time, but I have to determine what my pivot position is. So notice that I've got 2 over 1 as the first possible position. Of course, that's 2. And 10 over 1, which of course is 10. So the obvious choice then would be this one, 2 over 1. Okay? So that means that my new pivot position is going to be this position right here. It's going to be row 1, column 2. Okay, that's my new pivot position. So let's go ahead and pivot on this position, making everything else in this column 0. Well, one of them was already 0, so that's going to simplify some of our operations. And once we do that, we can take a look and make sure that all of our indicators are positive. Okay? If they're not, we just perform another operation. So let's go ahead and do that. So now I've rewritten the tableau corresponding to the first set of operations. Here it is. Okay? And notice the whole point was we first wanted to make the artificial variables non-basic. That was the first step. And we've done that. We've succeeded. Right? Everything in the column corresponding to A1 is non-zero. So clearly it's non-basic. The other thing to keep in mind, the other cautionary tale for this kind of non-standard linear programming problem is that once we've made the artificial variable non-basic, we don't want to pivot with regard to that column again. Okay, so maybe we would have had more than one of them. Well, we keep doing that until all of them are non-basic. But once they're non-basic, we leave them alone. Okay? Because we know that an optimal solution has the artificial variables equal to 0. Okay? If we can't make the artificial variables 0, then we know that the problem doesn't have an actual optimal solution. Okay? So now once we've done that, we leave that column alone, and it definitely is 0. Okay? So we're good. Again, what we want to do is we see that we're really trying to maximize, okay, and we see that one of the indicators is negative. So we know that we can perform another operation to go to another corner point where all of the indicators are positive. Okay, there's some leeway here. Okay, we haven't maximized all of our variables yet. So again, this was the pivot that we found from before. We want to pivot on this position here, which means that, of course, I've written the empty tableau here. The first row certainly will not change because that's our pivot row. Moreover, notice that the second position here, right below the pivot, corresponding to row 2, has a 0 in it already, which means that simplifies our lives a little bit. We don't have to do any operation on row 2. So I've rewritten row 2. That's not going to change. And also, the first thing we want to do is fill in all of the values that correspond to a 0 in my pivot row, right? Because if a 0 is in your pivot row, let's say there's a 0 here or a 0 here, you just get back the rows again. So in other words, those entries don't change. So certainly the first column doesn't change. That's a good thing, because otherwise it would destroy what we already did from the previous step. Okay, so we've got a 0, a 1, and a 0 over again. Moreover, my column corresponding to S2 is going to remain the same, so I have a 0 there and a 0. And of course, the column corresponding to Z will be the same as well, as usual. Okay? We just got to fill in these other couple of positions. So let's go ahead and do that. Well, we already, by definition, made everything in this first column 0. That's how we came up with these two operations. So I have a 0 here and a 0 here. Okay? Notice that they really do make it 0. These are the correct operations because I've got R3, 1 minus 1 would make that 0, and I've got a negative 3 plus 3 times this would make that a 0. Okay? So those are the correct operations. Let's go ahead and perform the rest. So now I've got R3 minus R1, so 1 minus 2 is a minus 1. I've got 3 minus 3 times row 1, so it's, well, that is 3 plus 3 times row 1. So it's 3 plus 6. It's a 9. Similarly here we've got a 0 minus 1, so a minus 1 there, and then a 0 plus 3, so we've got a 3 over here as well. And similarly here we've got a negative 3, right, plus a 1. Okay, so we've got a 2 here. Make that, what do we have here? We have I'm sorry, a negative, this is a positive 1 minus a negative 1, that's a 2. Okay, we were on the wrong column there. And similarly here, we've got R4. This is going to be a minus 15 plus the 3 times negative 1. So negative 15 minus 3 is a minus 18. It doesn't really matter what they are that much. All that matters is I know that that's just going to be 0 anyway, so it doesn't matter too much. And similarly over here, this column does matter, however. We have to be careful about this one. So for this particular position, we've got R3. R3 is replaced by R3 minus R1, so it's 10 minus 2, so that's a positive 8. And similarly here we've got negative 150, that's R4, plus 3 times row 1. So it's a negative 150 plus 6. Okay? So that should be a minus 144. Okay? If I can add correctly. All right, so we've got our tableau. Notice that this is the final tableau. This is the final version because all of the indicators are positive, so we can't do any better than this. Okay? This is the corner point corresponding to the maximum or the minimum value, the optimal value, I should say. Okay? It's a maximum of my minus W. Okay? And so now we've got the information we need. Notice that my basic variables are y1, okay, y1, and remember we go 1 here, we go across, so y1 is 8, and y2 over here, y2 is 2, okay, and y3, notice it's non-basic, so y3 is going to be 0, okay, and we've got a maximum of a minus 144 or a minimum of 144, right, because remember that we were trying to maximize minus W, okay, so let's go ahead and write down all of this in a more complete way. So we have the optimal solution. After we've performed all the operations and got to an equivalent tableau that led really to a proper corner point, once we read off all the proper information, here's the solution. The optimal solution is when y1 is 8, y2 is 2, and y3 is non-basic, so it's 0, and which corresponds to a z of minus 144. But remember that we changed the maximum to really, with a minimum to a maximum problem, which really means that ultimately the actual problem we were really after was we wanted to minimize w. Well, w is 144. That's the minimum value of w when this is my solution, when y1, y2, and y3 are that, okay, 8, 2, and 0. So we can achieve a minimum or optimal value when we have these values of our y's. Okay, so that's the solution to the non-standard linear programming problem where we have all kinds of these kinds of constraints, including equality constraints. Okay, so we had to include slack variables, surplus variables, and the artificial variables. The only thing that makes the procedure different is that we have to start with the artificial variables, make those non-basic first, and then we can go ahead and do the usual procedure as before, trying to make all the indicators the proper sign.